Hi, we're going to look at alternating series. And an alternating series error is an error that's tied to only alternating series, whereas Lagrange error bound is an error bound that we can tie to Taylor series, not necessarily ones that are alternating. So the error of an alternating series is at most the absolute value of the first term left out. Absolute value because we're not concerned with whether it's positive or negative. It's always absolute value when we're discussing error, whether it's Lagrange error bound or alternating series. In example 21, I accidentally left the answer here, so we're going to see how we got to those solutions below the example. So in part A, they're asking us to estimate the error if the first 100 terms of that sum is used. So if it's tied to the next term, that would mean that would be the 101 term that would determine the error. So we would say maximum error because error is that we calculate based off of this concept of alternating series error or Lagrange error bound is a maximum bound, and not actually the real error. So the maximum error is going to be tied to the absolute value because we are taking absolute value. That's going to take care of the alternating piece on top. So the absolute value of anything negative is positive 1 over the n plus 1 term squared. So if we cut it off at the 100th term, this is going to be n, the value of n. So therefore, the error would be 1 over 100 plus 1, or 101 squared. So that's how we get to the error for part A. For part B, sometimes they provide you the error and they ask you for the number of terms. So in this case, how many terms would be required to estimate the sum to be within 0.001? So in other words, if my maximum error is given as 1 over n plus 1 squared, that must be less than 0.001. Now, if I multiply both sides by n plus 1 squared to get rid of the fraction, and then divide over 0.001, another way of writing this expression would be 1 over 0.001 is less than n plus 1 squared. Now 1 over 0.001, which is 1/1000th, is the same thing as 1,000 is less than n plus 1 quantity squared. So if I now subtract 1,000 over to the other side, we would say that we would have the expression n plus 1 quantity squared minus 1,000 must be greater than 0. So if we subtracted 1,000 over to the other side, this is our new inequality. So I'm just going to have you guys explore. One way of solving this is to isolate the 1,000 and to then see what you would get if you were to take the square root of both sides. One other way is you can view this as a difference of squares. So if this is a difference of squares, then you can factor it as your a is n plus 1. So n plus 1 goes here and here. That's your a squared. Minus 1,000 happens to be 10 radical 10, and 10 radical 10 multiplies to be 1,000. So 10, so if it's a difference of squares and it has to multiply to be negative 1,000, then what we would do is have negative 10 rad 10 and positive 10 rad 10. So think about that for a moment. N plus 1 times n plus 1 is n plus 1 squared. Negative 10 rad 10 times positive 10 rad 10 is negative 1,000. And then the middle terms cancel out. So if that is all true, this must be greater than 0. So if I were to solve for this expression over here is going to get me a negative number of terms, which is not possible. So we're going to not consider that as an option. The other option would be for me to solve for n in this expression. So n plus 1 minus 10 rad 10 must be, let's actually set that equal to 0 just to find where my cutoff value would be. So in this case, if I add 10 rad 10 and minus 1, I get n equals 10 rad 10 and then minus the 1. So if I were to enter this into a calculator, let's see, 10 square root of 10, and then we're going to minus the 1, and we get 30.6. So n must be larger than 30.6. So the next term that would occur at would be 31. So it can't be 30 because it has to be greater than that. So my solution is 31 terms would be required for me to have a error bound of 0.0001. I might have said one too many zeros. 0.001.